All right, so we go to, let's look at the course itself. So course itself is what? So this, the F means function, right? If we open it, it has the proto, that is the prototype it received as an object. And it makes sense that that prototype is based on the function with the F keyword, with a capital F. So that is the constructor function of the function object. Okay, so the proto of the function is the prototype it received as an object. But there's another property called prototype, the full word. If we open it, it has its own name, right? So that is a prototype that we expect to be received by any object this function creates. So let's examine if that's the case. We have course 1 and course 2, you see here. Now the name of the constructor function is pointed out here, so that's a good advantage that it seems as if we created a type. Okay, but in reality, it is a function that set the proto object of that course 1. If we open it, we will see that its constructor is based on the course function. Okay. Now that constructor has a proto, which is the original proto, and we know where to stop. Now, if we looked at course 2, what are we gonna see? Something very similar. Now see how these objects were added directly to, these properties added directly to the object itself. Okay. And then again here, same properties added to the object itself. And both of them, if we open the proto of it, we will see that it was based on the constructor course. Okay. We can even, let's step inside the constructor function in order to see the properties added. So we're gonna stop with the first call here. Or maybe, let me just, I'm gonna stop here and then step inside. So at this moment, course 1 is undefined, right? Now I'm gonna step inside. Now we are inside the function. It has local variables. These are the parameters that were sent here, right? And then there is this points to that object after its proto was set to the course. But at this moment, it doesn't have any properties of its own. Okay? It has its prototype set to the course. But at this moment, it doesn't have any properties of its own. Now we are going to add a course name to it. See what happens. There you go, course name with the value sent in the parameter. And then next we add credit hours to it. There you go. And then we add the function to it. And then we go back. Now course 1 has a reference to that object that was created. Okay, same happens with course 2. At this moment, these are the local variables came as parameters, but the object itself, it doesn't have anything other than its prototype set to the course constructor. Now we add course name, credit hours, method, and then we go back with course 2 now pointing to that object. Okay, so that looks as if we did an instantiation like we used to do in Java, but there is a problem here. Now, these two objects are completely independent objects. So what does that mean? Let me just print here. We print a course name here, and then we print it again after we do what? See? I have the power to delete any property in that object. So let me just remove this and step here. So now we create course 1. At this moment, it just came from the constructor function with something called course name. Okay, so let's step over that. Now we're gonna try to print that course name. When we try, it prints, there is no problem because it was there. Now what happens when we try to delete? There you go. Now we change the object in course 1, but you see what happened in course 2? Nothing happened in course 2. Course 2 still have course name. So we can, the objects can be updated in different directions and we cause inconsistency. Now what happens if we try to print? Well, it's still, the script is still running, it didn't crash, but now print undefined because it doesn't exist. Okay? Now course 2 still as it was, there is no, I mean, we can have some objects going in different directions, we cause inconsistencies. But still, with deleting a property is not that big of a problem because the script didn't crash. Now, what if I try to delete the print name itself? Now, when we try to execute a function that doesn't exist, it just doesn't, it doesn't say undefined and continue, it will crash the system. So let's see. How does that work? Now we have print, first print, it prints properly. Now we deleted, doesn't matter. We deleted the function itself. Now, of course, one doesn't have a function called print name, but we still try to execute it, and now it crashes. Okay? So the ability to delete properties is might be problematic, but it's not, doesn't crash them. But the ability to delete functions is the more problematic way. So we need a better way to deal with that. And that's what we're gonna talk about next, using the class notation. Now, the concept of a class, you see what we've been trying to do with this constructor function. We were trying to resemble the object-oriented notation of creating a class that is a template and then instantiate it, right? Now, there is not a lot of difference in the internal implementation of JavaScript, but there is a what they call syntactic sugar. Okay, that's the code looks like we are creating a class, but in reality, it is exactly the same as we just learned about constructor function with some enhancements. Okay, now let's see. How does it look like if we use the class notation? We use a keyword class, all right, and then we give it a name. That name is the name of the constructor function, but the constructor function itself, we indicate it by the keyword constructor. Okay, so this is what we would put in a constructor function if we would use the rabbit name to it. And internally, it is still the same. But now it looks as if we are creating a class called rabbit that has a function inside of it called constructor. Looks like. Now, how about this? How about this? What's happening here? Now we know what's inside. Sorry. So when we get to instantiate, the instantiation part is exactly the same using the new keyword, and then the name of the constructor function. now looks as if we are creating it with the class keyword. All right. Now we know what's happening inside. This is exactly the same that we learned in the constructor function. This keyword refers to the newly created object, and it just adds properties to it. Okay, what happens here though? What is this? So this is a function that would be added to the prototype of the constructor function. Now remember, the constructor function has a property called prototype that will be set as a proto of the newly created object. So now, instead of defining functions directly to the object itself, we're defining a function as part of the prototype of the constructor function that will be set as the proto of the new object. All right. Does that mean that we cannot have functions directly to the object? We can. So like print name will be added directly to the object, but this one will be defined at the prototype level. Okay. So if we want to have properties like variables, something that is not a function at the prototype level, we can add it directly like this later on after this class is created. But if we are going to add it inside the curly brackets of the class, it is assumed that it is a function directly. Even we don't have to write the function keyword anymore. Okay. So when we add something to the prototype of the function, it will be accessible through any object. Why is that? Because this is just a pointer to an object, and whenever we change anything in that object, the prototype object, all the pointers referring to it. So the change will be reflected. Okay, let's see that's happening.